The two functions are equal here. Can you see that? They are giving an equal reading here. In our terms, we write that as cos theta is equal to sine theta, where the two functions are exactly equal. Where is cos theta equals to sine theta? Right? So how are we going to find the solution to that? In graph language, we just go and check, and then we read. In this case, it looks like it's halfway between these two angles. This angle here is 30 degrees, or pi upon 6, and this one here is 60 degrees. 30 plus 60 gives you 90, so halfway between that is 45. Okay? So, one solution will be 45 degrees. Another solution is here, between 210 and 240. 210 plus 240 gives you what? Don't worry, I'll wait. 350? 450. What is half of 450? 225? 225 is the solution. Good. If you press the sine of 45 degrees, it will also equal to the cosine of 45 degrees. In fact, that one is true because remember 45 plus 45 give you 90. If you press the sine of 225, you get the same ratio. What is the ratio, by the way? What is the ratio? It's negative 0 point something? 707, something like that, right? More or less. Okay. When you do this other one here, it's 0.7. Isn't that so? When you do the 45. In the ordinary level textbook, you know that question that you asked me? Where's that trigonometry? Okay, this is, you can answer this as well. Do you have your textbook with you? Yes. It's been used. It's book 2. Give me book 2 there. So, I wanted to find the 45 degrees and the 225 degrees using cos theta is equal to sine theta. How are you going to solve that in algebra? So I want to get somewhere. How will you solve something like cos theta is equal to sin theta? Not using a graph. You're smiling. You're smiling. The problem is you're smiling behind the camera. People can't see all those ivory that is in your mouth. And you have an idea, just try it out. While I quickly bring in this question. You guys will also remember this question from tomorrow. Give me that orange book of yours as well. I know it is orange book. They do have it somewhere else there. It should be there as well. Yeah. But anyway, do you have any idea how you will solve this? Okay. I can show you two ways of solving this, okay? Remember yesterday I gave you the first Pythagorean, not Pythagorean, but the first identity. The first reciprocal identity. Anyway, we said, and this is what I'm going to do. I'm going to divide both sides by cos theta. Cos theta. I can also divide both sides by sin theta. Okay? So when you divide by cos theta here, you get tan theta. Yes? We can calculate that thing. I'm just going to rewrite it as tan theta is equal to 1. So theta will be the inverse of 1, which all is 45 degrees. That is one solution. Right? But you also know that there should be another answer. And in which other quadrant is tangent positive? In the third quadrant. Tangent is positive in the third quadrant. So, this is what I managed to get. So, I know that this is the ratio, it just happens to be 1 upon 1. So, tangent is positive in the first, so this is the solution. But it's also positive in the third quadrant. And in the third quadrant, all the angles in the third quadrant are bigger than 180 but less than 270. You see? So what you're going to do in the third quadrant, because you remember it's opposite over adjacent, minus y minus x. Minus y minus x, that ratio becomes positive. It's not so. So it's this ratio, in this quadrant, it's going to be whatever the angle, you're going to do what? You're going to add theta. So in the third quadrant, it's pi radians plus the angle. So what is your angle that you got? 45 degrees. Now you find the answer for the third. You say 180 plus 45 degrees, which gives you 225. That's how it's done. You understand what I mean? Okay? The graph allows you to find solutions graphically. But if the graph is not nice, you will also have problems. You just get an estimation, right? But you should be able to calculate that. Okay, what if you make, what if you divide throughout by sin theta? If you divide by sin theta, and here is now something that F2. I can take this off, right? You have an idea? So suppose I was dividing by sine theta. This would be 1. But this here becomes cot. Cotangent is the opposite of the tangent. So every ratio has got the opposites. You see that? And we need to talk about that when we do our identities. You see that? In fact, we'll just take whatever our ratio is and we'll just take the inverse of that. Unfortunately, in this case, the inverse is just going to be 1 because 1 upon 1 is 1. Right? If that was a 2, we'll be taking a half. And then we change cotangent to tangent by swapping this. And then I'll write here tangent theta equals to 1 over 1. Now I'll swap it, but the problem is 1 over 1 will be just 1. And then I keep on doing the same. But I need to explain when we get to those particular, the inverses of when we get to that part. So that is why I was dealing, or yesterday, giving you the first reciprocal identity of the tangent in Newton is nothing but the sine divided by the cosine. Okay? So that's quite a scheme. So these two are co-functions. The curves are behaving in a very similar manner. If you take the whole, if I take the y curve, the sine theta, this curve, right? And I move this curve, I shift it from where this point is to where this point is. I shift it, right? What is the angle here that I shifted? From here to here. That's 270 degrees. That's 180 degrees. So if I shift it by what? What is the difference between 270 and 180? 90 degrees. If I shift the white one by 90 degrees to the left, it will be exactly the same function. Is it not so? It's just that this other part will now come this way. If I shift, please pay attention because I was saying to the left. Now, if I shift the pink one to the right, this way it is here, it's going to be here. So if I shift the cosine 90 degrees to the right, it's exactly the same thing. Is it not so? Are you still trying to check? Convince yourself. Sine, I will use angle of 90 minus theta. If I take the sine curve and I move it 90 degrees to the left, it's not going to equal to the cosine. I hope you understand where I'm going with this, people. Let's look at it again. Look at it again, please. There. If I take the white and I shift it 90 degrees to the left, it's going to be directly on top of that. It's just that one of the parts will come out, right? Because this end will be now there. Is it not so? Right? But then the other little part will come out. So when I shift my sine function, 90 minus, or theta minus 90, by 90 degrees, I'll come back to this. It will exactly be equal to the cosine function. So this should be written as what? You agree? If I shift the cosine function, the pink one, 90 degrees positive, cos is going to be, is it not going to equal to sine theta, for example? Okay, so maybe we have a little mistake there, so I want us to find it. And I was writing this time and again. Sine of 70 degrees is equal to cosine of what? Cosine of what? 90 minus 70. Is it not so? The two things will be the same. We'll revisit this again when we come to the other part. So you're going to learn something new. It's called a phase shift. That's what I was now referring to. I'm trying to go a little bit ahead, especially when I can mix all of the stuff. I like to do the sine and the cosine function first, and then we do the tangent one towards the end, because the tangent line is supposed to put more meat, different meat sources there in the sine and the cosine. Okay? If you look at page 155 in your book, there's a note that I wanted to highlight. The sine and cosine graphs are like good friends. They follow each other exactly 90 degrees. Follow each other exactly 90 degrees, or exactly half pi radians. There's one. Page 155. You get it? The sine and cosine functions are like good friends. They follow each other exactly 90 degrees. So when we come to other things, because there's only so much you can get from this information. So what we'll do is, we'll look at the sine function, which you should know starts from the origin. And then we're going to take also its opposite by putting a minus there. And we're going to try to draw them in the same curve, and then we're going to answer questions from there. The same with cos function, no minus. Minus here in front means the function is being reflected about the x-axis, for example, in this case. Is it not so? Alright? That's all that. And also the tangent. So the tangent goes like this, and when it's reflected, it goes the other way. Alright? But if the angle becomes negative, the function is being reflected about the y-axis, which means it goes on the other side. Negative angles. You see what negative angles actually mean, right? It means a reflection of the function on the y-axis. So it goes on and on and on. So there are going to be more solutions. For example, where let's take this function here, cos x is equal to 0.5. It will be at this angle here, which is 60 degrees. It will be at this angle here, which is what? What are we? 10 o'clock is what? 300 degrees. There's going to be another one as well, because it goes on and on forever. It's periodic. The functions are periodic, they repeat themselves up to infinity. That's why we call these graphs periodic functions. Okay? Then we're going to take something here, and we're going to do something else. We're going to add a number maybe, and we're going to affect the period, and we're going to stretch it, or even make it a little bit wider, especially with the fraction. You will see that. You don't have to draw that. We will do that so you can realize, and then you just complete the tables that are in your book. That's fine? Okay, I want us to look at the most interesting one. Cosine, the tangent function. We have to draw it to finish it. Alright? Did you draw the tangent graph already? Did you plot the points? Okay. You didn't plot the points? I'm a bit lazy to redraw. So you look at the graph of y equals to 10 feet. Just get my. I'm just going to estimate, right? Don't worry too much about these lines, they are there for a reason. Let me get my angles in. I'm going to use degrees so you don't get confused. 30, 60, 90, what is this? 120? There's another one here. 180, 210, 240, 270. 300 is here. 330 as well as 306. Did I not give out something? No? Okay. So, tangent of 0. 0. Yes? Tangent of 30 degrees. Make sure you calculate this in degree mode. Tangent of 30. Tangent of 45 is 1. Right? Tangent of 45, which is going to be somewhere here. I know the tangent of 45 is 1. So the tangent of 30 will be 0.6 or something like that. What? 0.7? 0.6. Okay, the way, what about the tangent of 60, for example? 0.8? 1.7. 1.7. Like 1.7 somewhere. Tangent of 80. Make 80.
5.7.
It goes up. Can you see that it increases? Yeah. I just want to know. Tangent of 88. 28 point. You see that it shoots up. Tangent of 89. Again, very big value. Right? Doesn't have an amplitude like the other ones. Do you understand that? But here's the thing, tangent of 90 doesn't exist. So it will get closer and closer. So this is what line? Asymptote. Okay, let's do another one. Tangent of 120. Remember in the first quadrant, tangent is positive. In the second quadrant, tangent will be negative. So where am I expecting the curve to be? It must be on this part, right? Right, so let's do tangent of 120. It's, what is it? Negative 1 point. Okay, so 120 will be somewhere down here, for example. Let's do 150. Negative 0.6, somewhere here. Now, let's do 180. It will be 0. Okay, good. Let's do 210. Now we are in the third quadrant, and in the third quadrant, tangent is positive, yes? So 210 will be 0.6. 240 will be 1.7 goes up. You agree? So I'm just going to.
No, so let's just put it there.
Here, there's, or here maybe, yeah. But basically, the curve goes something like this. Now, it will go closer and closer here. It will also go closer and closer, but the 270 won't exist. The 270 won't exist. So please remember, it's 90, it's 270. Let's do 300. This is the fourth quadrant, right? In the fourth quadrant, tangent is negative. Am I right? So the curve should be under. Right, so what is the tangent of 300 degrees? Negative 1.7, so it will be also somewhere here. What is it of 330? Negative 0.6? Yep. Of 360, it will be exactly under. Right, so basically, it comes, but it's going to go, right? What do you think is the next asymptote, the next line we will not cut? We had 90. Or cannot equal to 90. Cannot equal to 270. What can it also not equal to? Say? She kept it after every 180 degrees. So the curve repeats itself after every 180 degrees. So first we start with 90. Right? Good. So 90 plus 180. You see what? 270. 1. 270 plus 180 gives you. Don't know how to win. You.
So that's the next.
But it's now in the positive direction. You know? Okay? It's in the positive direction. 450. Say what? 630. So it's nice to know the 90. But it's what is the common thing here between these? Question. What will it be here on the negative side? Because it's going to come. So the formulation total of what? Did you say minus 90? How will we get minus 90? We're at 90 now. Subtract 180. Minus 90, subtract 180. Minus 90. Minus 90, subtract 180. Minus 270. So it's exactly the same, just with minuses. Now, if you look at the domain there, can you see 155? This is maybe where you need to highlight that. The domain X will not exist. That means the graph won't cut 90 degrees plus K times 180, where K is an integer. So if I put x here, or theta, theta is an element of all real numbers. Not so? But it will be 90 degrees plus some k times 180. You remember the other paper that I gave you? The other booklet, the one that I said, past question papers. Did you bring it? I want you to go there to that booklet so that you can look at something quickly. Because it's very important. That k is an integer. I said k is an integer. If k is 0, hello? If k is 0, it won't cut at 90 degrees. If k is 1, 270. If k is 2, what is 180 times 2? 360. 360 plus 90. 450. Is it also not the next point where we want to go? Okay, what if k is negative 1? Pay attention before you get to that paper. I know you are looking for a paper. I said k should be an integer. Integers are positive whole numbers, negative whole numbers, and 0. These are integers, the set of integers. Double z. When that is 0, is 90 degrees. It doesn't cut at 90 degrees. Yes? So the domain won't exist for that. You follow? Theta is not equal to whatever is going to be here. If k is 1, 180 times 1 plus 90 gives you 270. You also realize that graph will never pass 270. If k is 2, 2 times 180 is 360. Plus 90 is 540. So this is going to go 540, but it will never cut it. Now I decided let us use negative 1. If k is negative 1, it's negative 90. Because 90 minus 180 is negative 90. If k is negative 2, that's minus 360. Minus 360, 90 minus 360 gives you what? It gives you minus 270. You see that? So the k is your indicator, your integer value. Sometimes there's an n there or whatever, it doesn't matter, okay? The letter doesn't matter. Okay. What is the period? When does this hold? Is this a complete period of this function? Look here, the first quadrant, is it complete? It's not. Is this one complete? It's not, right? So between 270 and 360, which is 90 degrees, it's not complete. Between 0 and 90 degrees, it's not complete. But this is a complete curve between 270 and 90. What is the difference between 270 and 90? It's 180. So the tangent graph repeats itself every 180 degrees. So it has a period of 180. The sine and the cosine had a period of 360. The complete curve repeats itself after 360 degrees for the basic functions. Yeah? Which one starts at 0 again? Between the sine and the cosine? The sine. Which one started 1? The cosine. Okay? If you get confused, you can quickly type that in. What is sine 0? Right. What is cos 0? Then you have an idea. You understand that? On the calculator. So because you are not supposed to forget this basic shape of these curves. And it's very easy to confuse the two, the one that are like brothers. Now, that booklet that I said you must look for, did you find it? Oh, you think I gave you that for I have a workshop booklet. I also gave you the same booklet. This one. It's everything what you need to know in a high level and theme 1 in the AS level is in this booklet. It's the second one, eh? Not the first one. Graph paper. The graph book is white paper. In that cover, open. You will see somewhere under there. Take a bunch. The second booklet. Trigonometry. So, in short, I'm giving you this material, but I want you to also work through that. That is why I always refer you back to it. So so that you don't think that I just give you, bomb you with a lot of work. On page 111. 111, 112. Actually, go to page 100 and what is it? 115. Are you there? 115 in the booklet. Y equals to tan theta. You see that y equals to tan theta. They are saying there the period is 180 degrees. The asymptotes are plus or minus 90, plus or minus 270. And then you are given the range. Y is an element of all real numbers. The range is this value here. The other cosine and the sine, there's a range only between 1 and negative 1. But the range of the tangent, since it goes up to infinity and down to infinity, the range is just y is an element of all real numbers. But the domain has got restrictions. The domain has a restriction for values of 90 plus some integer multiplied by 180. So 90 plus minus 90, 270 minus 270, 540 minus 540. You get that from this. This is quite important for you to know. Okay. Also, while you are here, just look at the one under. When they are changing the amplitude, the graph of y equals to 2 sine theta. You know that the sine graph starts from the origin, right? But the moment they make a 2 in front of the sine, the amplitude changes. It means the graph goes now up, it stretches upwards. It still has the same period, but it just goes straight. So the moment the value in front, the amplitude, I hope you understand the amplitude. The moment it's a whole number and bigger than 1, it goes up by that much. If it's a 2, it goes, and 2 will be its maximum point. If it's a 3, 3 will be its maximum point. It's a fraction, it compresses by that factor. If it's a third, it will compress up to a third. From the center line, the graph says y equals to sin x, y equals to cos x, the center line is the x-axis. But it's not always that the center line will be that, because we're going to do something to the function, add things so that the whole function moves up, the whole function is translated to the left, to the right. I hope you'll get there. So the general shapes of the three functions, I hope by now, that is now something that is within you, that is stuck with them. Right? You have got posters in your class. The tangent one is here. It has always been here. This is between them. Because we only, you see, they went up 360 minus 360 to 360. It's always been here. You are told the period. You see, the period is where you have a complete curve.
Okay, I see.
So the period is that particular distance. This one here. This one here is our period. You understand that? After every 180 degrees, it repeats itself like that. Then you also have the asymptotes, because when you draw a tangent function, you must draw in the asymptotes with a dotted line to indicate that the curve won't go there. Then you also have range. Y is an element of all real numbers. It has always been there. There is actually more stuff here, right? If the two, if in front of the A, in front of the tangent,
yes,
if say A is equal to 1,
yes,
then Y values are at 45 degrees, 135, it's multiplied by what? Actually, bring that in more. Because there are so many information there that I want to take a picture of. You have to remove those facts. Okay? To start with the sine curve, you've got information here about the amplitude, and you have information here about the period, which we're going to have a look at. The stuff of, where's the other one? Cosine here. You have got information about the amplitude. The amplitude is whatever is in front of the sine, or the cosine, or the tangent, right? That number that is there. Bless you.
Oh, so the amplitude is already there.
The amplitude is what? The A value. Then the period is the B value. What is in front of the angle? If it's 1, period is 360. If it's 2, period is 180 degrees. There's a reason for that. So when you have a number in front, you divide it by 360. You will see exactly what it means, and that's what I want us to do. Okay? When you have a fraction in front, dividing by a fraction is the same as multiplying by that fraction.
So
by that number.
The period.
Yes. So you will see that part there, the period is the part that students normally struggle with. That is the part that I want to do. Right? And that is where I'm going to do it on that particular class.
That's why you're saying if the B value is a fraction.
Yeah. But the period, remember, what is the period? The period is obviously here. Something happens. Do you understand? If we put a 2 here, if we put a 3 here with the period, something happens when you put a fraction here. Because it's tangent, you'll be taking that number and divide it into 180. Because it's a tangent. If it's cosine or sine, you'll take that number, whatever is in front of that angle, you divide it into the 360. In order for us to see what our period would now be, how it will look like. You understand? So you need to, I can't make you now draw all these graphs. It's pointless, it's too long. The function is there and you will have an idea. And then there's a table that you can complete the table after that. Is that fine? So switch that on, please. So what is the period of a tangent graph? Just to do a quick recap. 180 degrees.
Pi radians.
Pi radians. Please be as much familiar with pi radians as you are with radians as you are with degrees. The box also, please. Thank you. And then take that thing from the laptop here. Push that on.
This one.
Okay, I think you can switch off the phone. Cut the tape.
Pi radians. Yeah. In the period for cosine.